Hello guys, welcome back again in our physics lessons. Today we are going to talk about how to interpret distance time graphs. Well, in this lesson we have four different distance time graphs. Each one has a different scenario. Well, in the first distance time graph A here, how to interpret this distance time graph? Well, as you see here, we have a curved line, a downward curved line. Well, in a distance time graph, when we have a downward curved line like this, that's mean what, guys? As you see here, this line here at this point, the distance covered is corresponding to 2.1 kilometers. But at this point here, at the end of the curved line, you will see that the distance covered is decreased. So that's mean what? That's mean the interpretation of this downward curved line is the speed or the velocity of the object is decreasing. So here, the velocity of the object is decreasing. The velocity is decreasing. And going to distance time graph B, as you see here, we have also a curved line. But this one here is quite the opposite to the first one, which is that the curved line is upward. So here we have an upward curved line. As you see here, for example, if we took this point here, we will see that the distance covered here is 1 kilometer. But within a very short time, we will see that the distance covered here is increased. So by the time change, we will see that there is an increasement in the distance covered. So that's mean what? An upward curved line like this in a distance time graph means that the object velocity is increasing. So here in this case, the object velocity or the velocity is increasing, which is the opposite to distance time graph A. So here we have downward curved line, which is mean that the object velocity is decreasing, and here we have upward curved line, which is mean that the object's velocity is increasing. As the curved line going upward, we will see that the distance covered is increasing by the time. So here we have a very short time, as you see here, from this point here to this point here, which is almost like 1.8 minutes, and we have a very long distance covered. So that's mean the distance or the velocity of the object is increasing. Okay, going to distance graph C. Distance time graph C here. We have here in the x-axis a distance in kilometers here, and this is here time in minutes. So here time in minutes. Okay, as you see here, we have a straight line. Well, how do we interpret a straight line in a distance time graph? Well, a straight line in a distance time graph means that the object is, as you see here. Before we say the interpretation, let us look at this straight line here. As you see here, during the first minute, the object covered a distance almost of 1 kilometer. During the second minute, we have also the same distance covered by the object. So here, a straight line means that the object is going with a constant speed or velocity. So a straight line in a distance time graph means what? Means that the object is moving with a constant velocity. So here the velocity is constant. The velocity is constant. Velocity is constant. What do we mean by constant? Constant mean fixed or not changing. So we don't have a changing speed here. So the speed is fixed For example, if it's going with 60 kilometers per hour, that's mean it's just going with 60 kilometers per hour during the whole journey. It's not changing, or the object is not changing its speed. Here we have distance time graph D. Here we have a horizontal line. Well, a horizontal line in a distance time graph means what, guys? Pay attention to this one, because later on in velocity time graphs we also will have horizontal line in velocity time graphs, and they have different interpretations. Well, here a horizontal line in a distance time graph means what? Before we go to or to describe this graph, let us see here. This horizontal line here is corresponding to the zero. That's mean what? We don't have, that's mean there is no increasement in the distance covered. So this line here, as time change, the line is horizontal. We don't have increasement in distance. So as long as we don't have increasement in distance, that's mean what, guys? That's mean the object is stationary. Is stationary. And stationary means what? Means that the object it is not moving. So if this line has just moved up a little bit, that's mean we will have increasement in distance. So the object, that's mean the object is started to move. But here, as long as there is no increasement in distance covered, so that means the object is stationary. So here, the object is stationary. The object is stationary. Stationary. And stationary means what, guys? Stationary means that the object is not moving. The object is not moving. So to conclude all this here, we have first here distance time graph A, a downward curved line like this one here, which is mean that the object velocity is decreasing, and distance time graph B here we have that upward curved line, and that's mean the object velocity is increasing. And here we have a straight line which is mean that the object's velocity is constant. And distance time graph D here we have a horizontal line which is mean that the object is stationary. Okay guys, see you in the next part.